Your spacecraft is falling toward a black hole, and you have 5 seconds to choose. Do you fire the engines, abandon the ship, or continue toward the event horizon? Choose now, because one decision could be your last. Before we begin, our destination is not a small stellar black hole. It is a supermassive black hole similar to Sagittarius A star, the monster at the center of our galaxy. Its mass is millions of times greater than our sun's. That difference matters. Near a smaller black hole, extreme tidal forces could destroy you before you reach the event horizon. Near a supermassive black hole, you might survive long enough to cross that boundary first. As your spacecraft approaches, the black hole does not look like an empty circle. Hot gas surrounding it forms a brilliant accretion disk. Light bends through warped space-time, making parts of the disk appear above and below the black hole. Behind it, stars stretch into arcs. Some light can even circle the black hole before reaching your eyes, forming narrow photon rings. You accelerate faster and faster, but your view becomes increasingly distorted. Light in front of you appears brighter, while light behind you becomes dimmer and redder. Now something even stranger happens. Time separates you from the rest of the universe. To a distant observer, your spacecraft appears to slow down as it approaches the event horizon. Your light becomes increasingly red and faint. From their perspective, you seem frozen just outside the boundary before fading from view. But that is not what you experience. Your own clock continues ticking normally. You do not feel time stop, and the event horizon is not a solid wall. For a sufficiently large black hole, you might cross it without noticing a sudden physical boundary. But the moment you cross, escape becomes impossible. The event horizon is the point of no return. Inside it, every possible path through space-time leads deeper toward the black hole. Turning around or firing the strongest engines would not save you. Even light cannot find a path back outside. You could still see light entering from the universe behind you, but you could never send a warning back. Then the difference in gravity between your feet and your head begins increasing. If your feet point toward the center, gravity pulls them more strongly than it pulls your head. Your body is stretched lengthwise and compressed sideways. Scientists call this spaghettification. Near a small black hole, this process could happen outside the event horizon. Near our supermassive black hole, it may occur after you cross it. Either way, the increasing tidal forces eventually become unsurvivable. No spacesuit, spacecraft, or known material could protect you indefinitely. As you fall deeper, the remaining time becomes frighteningly short. In a NASA simulation involving a supermassive black hole with about 4.3 million solar masses, a falling camera was destroyed by tidal forces seconds after crossing the event horizon. After that, it rushed toward the center, where our understanding of physics breaks down. This central region is commonly described as a singularity. General relativity predicts an extreme point where density and space-time curvature become infinite. However, scientists do not yet possess a complete theory combining gravity with quantum physics. That means nobody can honestly tell you exactly what ultimately happens there. Could information somehow be preserved? Does quantum gravity remove the singularity? Could a black hole connect to somewhere else? These ideas appear in scientific discussions and science fiction, but we have no evidence that falling into an ordinary black hole would transport a person safely to another universe. So, could you survive by choosing the engines in our opening challenge? If you were already inside the event horizon, no. Every route would lead inward. If you were still safely outside it, powerful engines might help only if you had enough distance, energy, and time to escape before crossing the boundary. The best survival strategy is therefore much simpler. Never get close enough to discover the answer personally. For a distant observer, you would appear to slow, redden, and fade. From your perspective, you could cross the event horizon, lose every possible escape route, experience devastating tidal forces, and finally enter a region where established physics can no longer predict your fate. Now make your final choice. Would you approach a black hole to witness this view if an advanced spacecraft guaranteed your escape? Or would you stay safely on Earth? Comment go or stay, subscribe to SciSpark, and watch the 60-second black hole challenge next.